I don't think I hit share screen, did I? There we go. Make sure my mic is on. Yes, we are. Okay, hello, everybody. Welcome back to Math 161. A couple of reminders before we get into Chapter 3. And if you did not catch the last lecture yet, we did finish Chapter 2 with inverses in 2.7 and then distance, midpoint, and the formula for circles in 2.8. So test 2, the review is still available. That review is in Canvas. The test is going to be available on Monday the 13th as of 12 a.m. And then it will be due by 11:59 p.m. Friday the 17th. I will give absolutely no extensions on this unless my math lab is down the entire week. If it's down for 15 minutes on Friday, that doesn't warrant an extension. If it's down for 10 minutes on Wednesday, that doesn't warrant an extension. Do not just try and take this test at 10:30 at night on Friday. Try it earlier than that. Your grade will thank you for it. Remember, you get 2 attempts. Count the best attempt. There is a 2-hour time limit. It is supposed to be no calculator, but obviously I'm not really, I can't do anything about that if you do. So just make sure that you have this stuff to the best of your ability without a calculator. Anything else I need to say? And of course, this needs to be your own work. Homework is due on Thursday the 16th. Besides that, let us go ahead and get into the new material so we don't dilly-dally. (3.1). So chapter 3, the main emphasis of chapter 3 is going to be on graphing. Graphing. That's the main point of this section, to learn more advanced graphing techniques. We've learned how to graph lines. We've learned how to graph some curves here and there. Another test. Someone just asked if the extra credit extended past 100 from the first test, will I apply it to another test? No, that just means you'll get 105 on your first test. So remember, if you completed the the prereq homework assignment, then I just got sidetracked. That was going to give you a 5-point bonus to test 1. So if your grade on my math lab says you got a 98, you really got a 103. The bonus is in there no matter what. Will you be asked to find the decimals of radicals? I would refer you to the review. So if you see something in the review, that means it's probably in the test. And if for some reason you were, you'd be allowed to use a calculator anyways, whether I say or not, so that would be okay. But no, you would not have to do that without a calculator. I would never ask that on a calculator-less test. Because I know we did an example with that last time, and I did mention in the lecture that I would not do that on a test, especially if there was no calculator. No problem. All right, so back to it. We've graphed lines, we've graphed some basic curves by just saying, hey, let's go from -3 to +3 in terms of x values in intervals of 1. So we ended up with like 7 points, and if you don't think that's enough, you could do 8 or 9 or 10 or 30 points. But that's such a random method for graphing, just putting in whatever x values you decide to, finding the y values, and hoping that you see the pattern. Now with lines, that's not a problem. The pattern is there everywhere. It never changes. All you need is 2 points anywhere. But these curves, these more complicated equations, things like quadratics, things that have x squareds, or cubic, something with an x cubed, then or exponentials, something like a 2 to the x, or rational functions, 2 over x, they have a lot more complicated features. Now, we did have a few basic shapes memorized, and one of them was the parabola, and it looks like a U, as we've discussed. So that's the general shape of any quadratic. So they tend to look like, oh, that's on highlighter. I found out that I have different colors inside a word, and these don't get erased, but the pen is a little thicker. So your parabolas tend to look like one of these two things. On a technical level, they can point left or right, but then they're not functions. So we just generally like these. And when they do point left or right, we're talking about the square root of x, because it's the inverse of x squared, and we only have one of the legs to make it a function. So this is the general shape that you should already have memorized. And in the last chapter, all we would do is plot one single point. We plot that point or that point, either the lowest or highest, depending on the scenario. And then we just said, okay, it's going to look something like that. Well, that's more of a sketch, as I said previously. We want to learn how to actually graph. So when I use the word graph now, I'm saying a much more accurate depiction, a much more accurate depiction of how wide or narrow these things should be. Now, at a minimum, we need 3 points in order to graph any parabola or any quadratic. We need 3 points. One of which needs to be the vertex. Now, the vertex is either the highest or the lowest point on a parabola. The vertex is the highest or lowest point on a parabola. That was the point that we were shifting around in the last chapter. We're going to learn other ways of finding that vertex soon. So the vertex, remember we say the vertex as a point we called h comma k. Why do we choose these letters? Because some mathematician or mathematicians 100+ years ago decided to use those letters, and we just stick with it. Okay, so this at least a 3-point method, and that's at a minimum. 4 points is good too, but 2's not enough, 1's not enough to get an accurate depiction. You're going to determine whether the parabola opens up or down based on the sign of A, and I'm going to get to this in just a second. What do I mean by the sign of A? Just pause for a minute. If A is positive, it opens up. If it's negative, it opens down. So let me clear a little more space. There we go. Oh, and the nice thing about when I do this in Word instead of in my quote annotate package, look, the stuff actually scrolls with it. I don't have to clear my screen, so that's nice. All right. So our standard form, I'm going to skip these steps just to get something else written up here. Of course, we're coming back to it. Standard form, also known as vertex form of a quadratic is f of x equals a parentheses x minus h, close it, square it, then plus k. This is an extremely important format for quadratics, for these parabolas. A lot of people are used to seeing an ax squared plus bx plus c, and that's great for factoring. That's great for a lot of things, and it's pretty solid for graphing quadratics. But this format is amazing because when something is in this format, the reason I like to call it vertex form instead of just standard form is because you can tell me in less than a second what the vertex is. You got in the parentheses x minus h, so whatever number this is inside of the parentheses would be the x coordinate of the vertex. But notice that this has a minus, which means that it changes signs. We were dealing with those issues last class. But then over here, you have a plus k, so that's the y coordinate of the vertex, but it does not have a minus, which means it does not change signs. Think back to when we learned about how to shift graphs around with a basic core. So like an x squared, you move it right this much and up this much because of the number inside and outside. The number inside was always backwards. And in this formula, that's a minus, which means it's backwards. But the number outside, the vertical shift was always the same. Plus meant up, which is why there's no minus here. That's the same. So the inside, you'll have to change the sign to get the x coordinate. The outside, you will not. So this is a very small detail that you have to keep track of. Now the A here is the A I was mentioning above. So there will be a number in front of your parentheses with your x blah, blah, blah squared. If there is no number, it's assumed to be a 1. So let's say there was a 2 right here. That would be positive, which makes the graph open up. Let's instead say this was a -2. If this A was a -2, that means that the graph opens down. Guess what that follows directly? that follows the idea of a vertical reflection, that a negative outside flips the up and down. So this format completely agrees with every single thing we learned about shifting and reflections back in chapter 2. Again, this format is awesome because you can immediately tell the vertex, which means you're already plotting the lowest or the highest point. Sorry for that. Then the A tells you whether it opens up or down, and then you just get some extra points. So identify the vertex. All you gotta do is this number and this number. There you go, there's your vertex. Be careful with the signs. Step 3 and 4. These are going to be very common steps in chapter 3. These two steps are in pretty much everything of chapter 3. Finding an X-intercept or multiple X-intercepts if they occur, and then finding the Y-intercept. And I should actually depluralize that. There is only a single Y-intercept. I don't want to confuse you. So how do we find an X-intercept? Well, remember that intercepts always have 0 opposite the name. So an X-intercept is always some point, comma 0. That's an X-intercept. So that means the Y value has to be 0. Y and f of x are interchangeable. We were literally interchanging them in 2.7. So that just says set the function equal to 0 and solve. Now these are going to be quadratic, so you may have to factor, you may need the quadratic formula, you may be completing the square, you may be using the square root property. There's all sorts of options. These are not the only two things. I'm just giving two possibilities. To find the Y-intercepts, well, a Y-intercept has an x value of 0. What happened? There we go. So to find a Y-intercept, you set the x equal to 0. The x is the inside of the function. And again, you will only find one of these and you'll always find one of them. Spoilers, you will not always find X-intercepts. Sometimes there's 2, sometimes there's 1, sometimes there's 0. So the vertex will be the first point you find. You'll always find it. The X-intercept will either be the next 2 or 1 or no points you find. Could be any of those 3 cases. Then you'll find the Y-intercept. So once you find that Y-intercept, you may actually have 4 points, you may have 3 points, or you may have 2 points, which is why this step 5 says plot any additional points if needed. Use symmetry if you're able to. I suggest staying close to the vertex. In other words, I'm just saying to plug in an X value of your choice if you want, or to use symmetry, and I will demonstrate both of those. I mentioned to stay close to the vertex. If your vertex is at x equals 3, you don't want to plug in x equals 1,000,000 or x equals -70. If your vertex occurs at x equals 3, plug in 2 or 4 just so you're staying in that ballpark. Trust me, it's going to make things a lot easier on you. Stay close to the vertex if you're just picking another x value. So I have talked about this before, but I'll just redraw these pictures. There's 3 basic cases for graphing parabolas as functions. Now these could all point down instead. I'm just going to draw them all as pointing up. Here's case 1. Here's case 2. And here's case 3. Case 1 crosses the x-axis twice, so that's 2 X-intercepts. The second one crosses it once, so that's 1 X-intercept. The third case has no X-intercepts. We related this to the discriminant back in the previous chapter, well, chapter 1, I believe. So that all related to the discriminant, but you don't have to calculate the discriminant. It would just tell you what to expect. But when we draw these pictures, these are the things we'll start seeing and what we could end up expecting. So these are the 3 possible cases in terms of the X-intercepts. But there's always a Y-intercept. There's always going to be a Y-intercept. Now, I don't technically have it shown on the middle one, but this is going to cross it a little bit up here somewhere. Oops, undo. somewhere up here, probably about right where the A is. So I didn't write anywhere that the vertex is the highest or lowest point, but I did mention it several times. I'll still type it. The vertex is the highest or lowest point on a parabola. It can't be both. It's one or the other. And then finally, the axis of symmetry, as opposed to the axis of evil, sorry, history joke, is the vertical line x equals h. This is something that I really like to stress. The axis of symmetry is a vertical line. Now, I'm not saying that these functions are even necessarily. I'm just saying that they have a symmetry with respect to themselves. Every single one of these things, if you drew a dotted line, a dotted vertical line through the location of the vertex, we would call that the axis of symmetry, because if you go left 3, wherever you have a point of a certain height, let's say the height was 10, if you go left 3 from that axis and there's a point with a height of 10, that means that there's also a point with a height of 10 if you were to go right 3. That's what I mentioned earlier, to use symmetry if you're able to. That's going to be the quickest thing to do should you ever need additional points besides the vertex and intercepts, which is generally only the case if there are no X-intercepts. If you got 1, you might already have 3 points. If you got 2, you definitely have your 3 points. So let's say your graph ended up looking like this. If I ask you for the axis of symmetry, or if my math lab asks you for the symmetry, you're supposed to make a dotted line, a vertical dotted line, splitting that in half. That is the axis of symmetry. Now that point right here, that's the point h comma k. So this is a vertical line. It has to be x equals a number, and it has to be the x coordinate. We've talked about that. I'm going to run out of room. The only downside of using Word is I can't write on the margins. So your axis of symmetry, let me just scroll down a little, is x equals h, and that'll be a number. So if this point was 3 comma 4, this would be the equation x equals 3. If this point was 1,000,000 comma 1, and all those would be negative, obviously, but if this was 1,000,000 comma -1, then the axis of symmetry would be x equals 1,000,000. So please pay attention to whether the instructions ask you for the axis of symmetry, because my math lab is cruel. If they ask for the axis and you don't do that vertical dotted line, it's going to mark the whole thing wrong. Or if they don't ask for it and you give it, unfortunately, it will also mark everything wrong. So again, I'm really trying to emphasize paying attention to instructions. Pay attention to the instructions. If they don't tell you to do something, don't do it. So again, this 5-step process. The A tells you whether it opens up or down, based on it being positive or negative. Then you find the vertex based on the form. Find your X-intercepts by setting the whole thing equal to 0. Find the Y-intercept by plugging x equals 0 in. Then additional points if needed. Symmetry is great to use for those if you do need extra points. All right, so let me switch to the whiteboard. So we can do example 1A. Example 1, and I'm going to say graph include, I'm going to make this a little thicker. Oh, that's not going to work. I'm experimenting with stuff lately. Is this just lines? Yes, it is. Okay. Graph include the axis of symmetry. So for A, we're going to have f of x equals -2 parentheses x minus 3 squared, and then a plus 8. So this is a quadratic. How do I know it's a quadratic? Because I see an x and a square. I don't see any x cubes. I don't see any x to the fourths, no square roots, no variables and denominators. So this is going to look like one of those U's. If you want to identify your numbers, because there's a -2 in front, that says A is -2. Because the inside is a -3, remember this switches signs. You have to practice this to get that down. That makes the H a +3. The K, the Y value of the vertex, however, does not change signs, so that's a +8. Because the A is negative, it's going to open down. Again, that's based on the A being negative. If it was positive, it would open up. Now here's what's cool. If you don't actually identify this, as long as you get your vertex and your 2 additional points at a minimum, it's going to open up or down appropriately anyways, as long as you don't make any mistakes. In addition to that, with the H and the K known, we have our vertex. That lowest or highest point occurs at 3, 8. And since this opens down, it would be the highest point. So that was step 1. All right, next, we want to find the intercepts. Now, honestly, it doesn't matter the order you do them. Let me go back to the other screen for a second. Step 2, 3, and 4, there is literally no reason to do them in any particular order. There's no reason to do number 1 in any order. You can do these completely in backwards order, 4, 3, then 2, then 1. It doesn't matter. So we determined the sign of A. We also did the vertex. That was step 2. Now let's do the intercepts 3 and 4. Again, the order I do them doesn't matter, but I'll be consistent. Let's do the X-intercepts first. I'll switch colors to make this. And that's where we set f of x or y, because they're not always written f of x equals. It could be given to you as y equals. So that's where we're setting the output equal to 0. So we go 0 equals -2 parentheses, x minus 3, close it, square it, then a +8. And then we got to solve this equation for x. Now you've got several options you can take. You can take this parentheses, multiply it by itself, FOIL it, then distribute the -2, then combine the 8, and then at the end of the day have to factor all of that. And that was a lot of things to have to do just to get down to x equals. And it works, but it's a lot of stuff for this problem. I would never do this problem that way, whether or not half of you want to. Since I have a parentheses squared, what I would really like to do here is apply that square root property where we isolate the parentheses and then do something to both sides. So let's isolate the parentheses here. To do so, we'll subtract 8 on both sides, which will give us -8 is equal to -2 and then the parentheses, still being squared. Next up, let's divide both sides by -2. To isolate the parentheses. Again, that's the goal here, be goal-oriented. So that'll give us +4 equals just the parentheses of x minus 3 squared. Now remember, when we have something squared equal to a number, unless this is a geometry problem, you are supposed to take not just a square root of both sides, a plus or minus. I told you that issue was never going away. So plus or minus square root of 4. Let me undo the green on the 4. And then the square root without the plus or minus on the other side. We do that because square roots and squares cancel. Let me continue my work up here. So that's plus or minus, the square root of 4 is 2, then equals, the square root and the square cancel, so that just gives us an x minus 3. But that says x minus 3, so we got to add 3 to both sides. There's a plus or minus there, so you better put it in front. I've focused on that technique before. So that says, wrong color, 3 plus or minus 2 is equal to x. Now, if that was a square root of 2 or a 2i, you'd stop here. First of all, if it was a 2i, that would mean there are no x-intercepts. If there's imaginary numbers, that means no x-intercepts. Again, that relates back to that earlier chapter with the discriminant. Intercepts have to be real numbers. So because there's no radicals, there's no i's, we need to separate these cases. So 3 plus 2 would be 5. 3 minus 2 would be 1. So those are the two x values. There's 2 of them. This is not the point 5 comma 1. This is not the point 1 comma 5. This is not, these are not vertical lines of x equals 5 and x equals 1. These are the x coordinates to the x-intercepts. Remember, intercepts always have a y value or x value of 0. We set the function equal to 0. That was us saying that y is 0. So these are only half the numbers. That tells us our x-intercepts are 5 comma 0 and 1 comma 0. So we just found 2 points out of those 3 graphs we drew a few minutes ago. The 3 possible scenarios. This is the first one. Hold on, give me about 15 seconds. All right, had to get my water. So we got 3 points we found so far. Huh? I thought that was just 2. Don't forget the vertex. So we have the vertex and 2 x-intercepts. In all honesty, that is enough to make a parabola because you just need 3 points to really make a good parabola. But if we can find a y-intercept, that is always a great point to have. So let's do that next. Let me switch colors. I'll go back to black. So for the y-intercept, remember, singular, there can only ever be 1, and there will always be 1 for this. That's where we set x equal to 0. So we go back to the original function. We are doing f of 0, which is negative 2 parentheses, 0 minus 3 squared, and plus 8. 0 minus 3 is negative 3. So that's negative 2 times negative 3 squared plus 8. Negative 3 squared is positive 9. So that's negative 2 times 9 plus 8, which is negative 18 plus 8, which is negative 10. So that tells us that our y-intercept is 0 comma negative 10 because we plugged x equals 0 in. Now we have 4 points. Let's go and just mark our 4 points. So we had the 3 comma 8 is the vertex. We had the 2 x-intercepts and the y-intercept. So 3 comma 8, 5 comma 0, 0 comma negative 10. We definitely need a pretty sizable graph. I don't want to do it there. Let me try something. It's really weird using something like a ruler when you can't watch. There we go. Okay. It's positive 9 because we have negative 3 squared. Negative 3 times negative 3 is positive 9. That's a little dot there. It's not a negative. So that should be negative 18, and then that'll add a negative 10. No worries. Thank you for making sure we're all good. All right, so in terms of left and right, the furthest right number I have is a 5. So let's go right. 1, 2, 3, 4, 5. I'll go to 6 just to be thorough. In terms of the y values, we got one of them as high as +8, and then one of them as low as -10. So we need to go a little further on those. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to mark the furthest ones out so far. Vertex, 3, 8. I'm even going to do that one in red for emphasis. Right 1, 2, 3, up 8. There's our vertex. Some people like to put a little V here as a reminder. You could do that too. The rest of them I'll do in blue to distinguish from the axes. So next up, we found the X-intercepts of 5, 0, which is right 5, up or down nothing. Then 1, 0, which is right 1, up or down nothing. Then a Y-intercept of 0, -10, which is left or right 0 and down 10. So we have these 1, 2, 3, 4 points where the red one has to be the highest or lowest. Since it opens down, that is definitely the highest. This is the peak of it. So in other words, it's going to have to go down from there, like that somehow. But instead of just drawing that one point and oh, maybe I want to do it like this. Or maybe it's supposed to be really tight like that. I don't know. Instead of just guessing, now we have points to guide us and how far it should be bending. So something like this, just to go to those 2 points, and then to go to the -10, it gets, God bless the undo and redo button. There we go, that's pretty good. I could have done better. So that's connecting the 4 points. Now you don't want to leave your parabola just looking like this. It looks a little goofy. I always like to extend past the points, and I like to make this symmetrical looking. So I'm going to keep going down and right on the other one, like so. Sorry, it got a little squirrely there. And the same thing on that one. That, I would say, is the finished product of just the parabola itself. So again, we now have a much better idea of how wide or narrow this thing should be because of the extra points. And honestly, again, this -10 down here to make the graph, quote, accurate is unnecessary. However, in these sections, if they ask you to graph, they expect the intercepts to be found. So don't just stop at those two. Find the Y-intercept as well. But I did ask for one other thing. We asked for the axis of symmetry. So that's a vertical line that splits this thing in half. I'll do it in neon green. As best as I can. So that is our axis of symmetry. And you are supposed to write this as an equation, x equals a number. Do not just write the number, it has to be x equals. Without the x equals, you are not depicting a line that is vertical. And then that number is the x coordinate it goes through. Well, it goes through 3, so that's x equals 3. And if you don't believe me, look where it goes through on the x-axis, that's 3. There it is in all its glory. A picture of a parabola, much more accurately depicted than in the previous chapter. There is no guessing as to how wide or narrow this thing should be. And what's fascinating is this is not the only way to graph parabolas accurately. When you go into Pre-Calc 2, we approach this from a more geometrical standpoint, having to do with what we call conic sections, which involves ellipses and hyperbolas and circles and parabolas. So that's interesting. Some of you won't go into that. Some of you will. But it's not in this class, don't worry. So what do? The A tells us whether it opens up or down. Well, good thing this thing agreed with us. It opened down when we painted the picture. Honestly, like I said, it doesn't have to be done. If you've mastered this stuff, this is more of a self-check. We found the vertex based on the form. So there was our H and our K. We found the intercepts by setting the function equal to 0, and then the inside equal to 0. Setting the function equal to 0 is the X-intercept. Setting the inside equal to 0 is the Y-intercept. Then we plotted. We made our axis of symmetry because we were told to. And now we can do another example. So same instructions, we're going to graph and we're going to include the axis of symmetry. So for B, let me go back to black. What do I have? F of X equals parentheses X plus 4 squared, close it, and then a plus 2. Okay, so first step, let's identify the A. There is no number written in front of the parentheses, which implies that it is A, drum roll, positive 1. Remember, if there's no number in front of something, you can always say there's a positive 1 in front of it. So the A is 1, which means that the graph opens up since it's positive. We can also identify the H and the K because this is in the very special, very awesome format that things are not always given to in that way. We'll see that later. So the H and the K. Now remember, one of these changes signs, one does not. And if you flip a coin on test day, you're probably going to get it wrong, in my opinion. I feel like when people flip coins in their head, you're more likely to get it wrong, even if it's a 50-50 shot. I don't know why, it just seems to be the way things work. It's the inside that's opposite. So since that says a plus 4, the H is negative 4, the K takes the direct sign, it's positive 2, which makes the vertex the most important point of all of this, negative 4, 2. You cannot make a parabola without the vertex. You have to know where the highest or lowest point is. So if you just find 3 random points, maybe they're all on the left side of the dip, maybe they're all on the right side of the dip. Maybe it's 2 and 1, but you need that lowest or highest point. It's not just 3 random points, it's the vertex and then some other points, but the vertex is the most mandatory. You can graph parabolas without finding intercepts. We just like this because it means we're plugging in zeros. Zeros are easier to plug in. So next, we'll find the X-intercepts. This is where we set f of x equal to 0. I want to keep reminding us of that for a little bit. So we go 0 equals parentheses x plus 4 all squared, then a plus 2. Now again, if you want to take the long pain in the butt road, you can take that parentheses, multiply it by itself, FOIL it, combine like terms, combine the 2, then factor. And it might not even be factorable. You might have to do the quadratic formula on some of this stuff. And believe me, that's going to frustrate you, especially knowing that the alternative method, the one we're about to do, is only a couple of steps. And it's the same as the last time. Because we have a parentheses squared, let's isolate that and then take the plus or minus square root of both sides. So let's subtract the 2 on both sides, which will give us negative 2 is equal to parentheses x plus 4 squared. Now we take the plus or minus square root of both sides. Plus or minus only on the number side. Where are we, blue? The square roots and the squares on the right will cancel. The square root of negative 2, we don't know the square root of 2, but we know that anytime we have a square root of a negative, we, and it sounds gross, pull out an I. So this is plus or minus I times the square root of 2. That equals x plus 4. Now we're going to subtract 4 on both sides to finish solving this. I did not leave myself too much room. This is me putting it in front of the plus or minus. Sorry about that. So that's negative 4 plus or minus I square root of 2 is equal to x. Now that's 2 different intercepts in theory because of the plus or minus, but this is an I. We said that intercepts have to be real numbers. We have no idea at this point in our lives how to graph imaginary numbers. You can graph imaginary numbers, but you're going to need some 400 level mathematics first to do that in college. So we can't graph this. It means there's no X-intercepts. That was the whole reason the imaginary numbers had the name imaginary. It's that their intercepts, their X-intercepts are imaginary. So all that work we just did, it feels like it was for nothing because we didn't even find 2 points. But at least now we know it doesn't cross the X-axis. That is beneficial. All right. Next up, what color did I do after that? Just want to be consistent. I did black. Okay, that's what I thought. So now we'll do the Y-intercept, singular. That's where we make the X value 0. We're plugging in 0. So f of 0 is parentheses 0 plus 4 squared. That is a 0. Then plus 2. 0 plus 4 is 4, so that's 4 squared plus 2, which is 16, plus 2, which is 18. So therefore, our Y-intercept is 0, 18. Again, 0, 18. Let me be a little cleaner with that 0. So far, we found the vertex, and we found the Y-intercept, and we said there are no X-intercepts. We only found 2 points. This is worst case scenario. That doesn't mean that we can't finish. It doesn't even make the problem difficult. It's just the worst case scenario. So let's plot what we have so far and see what we can do. All right, so let me try this fake ruler out again. How far? 0, 18, so we need this pretty high up. We don't have to go very far left or right. No, here. Get my eraser. Here we go. All right, X, Y. So the vertex of -4, 2, that's left. 1, 2, 3, 4, and up 2, 1, 2. That's -4, that's 2. And I said I'll do my vertices as red for emphasis. There we go. And then we had the Y-intercept of 0, 18. We were doing blue for that. Well, I need to label up to 18. I hope I went high. I can go high enough here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Definitely need to go up more. "13, 14, 15, 16, 17, 18. 18. Come on, it won't let me write that high. I'm just going to say that's 18. So there's a point way up here. Now let's draw the axis of symmetry. I need to move this thing out of the way. So the axis of symmetry is just a point going through the vertex. I said a point, a vertical line going through the vertex. I can draw that without the rest of the graph. And that's the equation. The axis of symmetry is x equals -4. Now, I mentioned something previously. We said this highlighter part. We can use symmetry to find another point. You don't necessarily have to plug in other x values. Symmetry is going to be the easiest way to do this. So let's try that approach. Let's see if we can understand what we mean there. So the right side, we have a good depiction of what it should look like. Here's the vertex. Here's an intercept, so I can connect those with our standard looking parabola. It's going to be pretty steep on that part, and then it'll start flattening out the closer you get. And it might be a little flatter in this region. I'm just doing the best I can by hand. So that's what the right half of this graph looks like. Now, this is a mirror. This dotted line is a mirror. So any point, let's say there's a point 1 to the right, there's a mirror of that 1 to the left of the axis. This height of 18, this point, the distance from the axis to that point, we're at -4, so that's 1, 2, 3, 4. So I'm just showing the distance from the axis to that point. What this means is there is another point of the same height if you were to go 4 to the left of that. So if I go 4 left, I need to do this. -5, -6, -7, -8. So if I go 4 to the left, there we go. That says that there should be a point of the same height. And I'm going to write that down in just a minute. But now I can see that the left side should look like a mirror image of the right side, depending on your teacher's artistic ability or lack thereof, especially with weird technology. Boom. And I don't know if it's going to let me. It will not let me draw any higher, but I was just able to squeeze in an arrow here. That should be on the right side as well. I apologize for that technical limitation. But there, I do, as I said previously, like to just go a little past these and then put an arrow on them. So again, I have it on the left one, just barely, but it's on the right one as well. So let's text. So by symmetry, 0, 18 is 4 to the right of the axis of symmetry. So -8, 18 must be a point 2, because that's left 4 from the axis of symmetry. I didn't have to do any math, and if you don't trust that, plug in x equals -8 into this function. -8 plus 4 is -4. -4 squared is +16, and guess what 16 plus 2 is? It's 18. It saves us time from having to do arithmetic and algebra. Are we always going 4 to the right and left? No. This distance is arbitrary. It's just a matter of where the point was located. If I had a point at -3, I don't know, 5, since that's 1 away from the axis of symmetry, that means we have a height of 5, 1 to the left from the axis of symmetry. Okay. So let's go back to the screen. And I have some stuff up here that I don't want to talk about yet. Nope, not that. That. Let's talk about the other form. So we mentioned earlier, standard form right here, also known as vertex form of a quadratic, is this f of x equals a parentheses x minus h squared plus k. We love this form because it immediately tells us the vertex. It immediately tells us whether it points up or down. And then honestly, it's usually not that much work to find other points as long as you remember the plus or minus square root property. But there's another form, and it's called, and it's extremely boring, the general form. And this is really right here. F of x equals ax squared plus bx plus c. It looks a lot more like what we try and factor and do quadratic formulas with. This form is not as friendly. A, B, and C are just numbers here. It's the same A. So the A still tells us whether we point up or down, but the B and C are just numbers. They tell us nothing about the vertex in that format. Well, if you wanted to do a bunch of fancy algebra and proofs and stuff, it can be shown, calculus helps too, that in this format, you can find the vertex by this formula. H equals negative B over 2A. So that's a formula you'd have to memorize. There is also a formula for K. I will not write it down. I have never written it down in one single algebra class in my life, and I never will, because it is a pointless formula to remember. All you have to do is plug it in. It's f of h. H is the x coordinate. We always find a y coordinate by plugging in the x coordinate. That's all I'm saying. Oh, that was a terrible squiggle. Let's try that again. Much better. All we're saying is plug in the x coordinate of the vertex to find the y coordinate. This is not a complicated formula to remember. In fact, if you remember your quadratic formula, which you better, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Look at this right here. Look at this right here. It's the same thing. It is not a coincidence. I told you that quadratic formula was a threefer when we gave it to you. Not only does it give us the solutions or the x-intercepts, it also gives us the discriminant. Remember, the discriminant was the inside of the square root. And on top of that, it gives us the vertex. And the reason is because adding or subtracting, this right here, this plus or minus, is the symmetry feature. If you want to go right or left, you have to go right and left the same amount. So you do have to memorize this simple formula, which was already part of a more complicated formula that you were supposed to memorize. So this is a 3-in-1 formula right here. And again, there is technically a formula for K. I will never, ever, ever write it. So this is called the general form. The other one was supposed to be called the standard form in most math books. You'll see some math books call it the vertex form, and I'm a bigger fan of that name. And the reason is standard general. I see no distinction in that. Why is this the standard? Why is this the general form? Why couldn't the first one be the general form? Why couldn't the other one be the standard form? There's nothing that really distinguishes the namesake for it, which is why I love vertex form. I love names that tell me something about it. Oh, vertex form, the vertex is staring you in the face. Then the other one, I don't even care what this is named. I really don't. Standard, general, blah, blah. It's just you have to know how to use it. And the vertex will no longer be staring you in the face. You got to apply a formula, but thankfully a simple formula. All the other steps are the same. You're still going to have to, once you find the vertex by the formula and plugging it in, find the x and y-intercepts, additional points if necessary. So h equals negative b over 2a when we're in the ax squared plus bx plus c form, the form that looks like it would be factorable. Maybe, maybe not. Depends on the numbers. All right. Example 2. Graph. And let's say all important features. I tell you what, the whatever AI they've got in that word writing thing makes my handwriting look a lot better than this. Unfortunately, it just isn't perfect for everything, including the axis of symmetry. For A, let's go with f of x. Remember, I could write y equals, that doesn't matter. X squared minus 5x plus 6. So if you like to identify important numbers, this is not in vertex form, this is in the other form. So the A is 1, the B is -5, and the C is 6. The same way we'd be identifying things for the quadratic formula in the past. Now the A still tells us whether it opens up or down. This is the exact same A no matter what form it's in. So that says it opens up. Again, that was because of the A. Now let's find our intercepts. Rearrange this again. Come on, you can move. Please move. Okay. All right, so the X-Intercepts. Remember, that's when we set the function equal to 0. So we go 0 equals x squared minus 5x plus 6. I can't guarantee this is factorable, but that's the first thing you should try. If it's not factorable, you'll need that quadratic formula that I just so friendly, I was nice enough to remind us. But this is factorable, trying to find a pair of numbers that multiply to +6 and add to 5. Since I got to add, it's 2 and 3. So it goes 0 equals x 2, x 3. Now we got to make sure they add to a negative, so they both have to be negative. Remember, factoring is supposed to be on point. There was no AC or trial and error needed because the leading coefficient was 1 here. Then we use our 0 product rule. So we set each factor equal to 0. So setting x minus 2 equal to 0 and x minus 3 equal to 0. I'm going to skip showing the algebra here. It's add 2 and add 3 to both sides. You get x equals 2 and x equals 3. So we get the point 2, 3, right? Question mark, question mark, question mark. No. This is not the point 2, 3. These are all x values of x-intercepts. Intercepts always have a 0 in them. Particularly, x-intercepts have a y value of 0. So our x-intercepts are 2, 0 and 3, 0. They're really close to each other, in fact. And that's okay, nothing wrong with that. Next up, let's find our y-intercept. That's finding f of 0. We're making the x value 0 this time. Well, that's 0 squared minus 5 times 0 plus 6. Finding a y-intercept in this format is spectacularly easy. It's always the constant. All the other stuff's just going to go away. So f of 0 is +6, meaning that the y-intercept as a coordinate pair is 0, 6. So we got our vertex, right? No, we never found the vertex. I did this intentionally. I said that you don't have to do everything in a particular order, so I mixed the order up a little bit. I'm going to do that last. I could have done it first, I could have done it second, I could have done it third, I could have done it last. But so far we have 2 x-intercepts and 1 y-intercept, but that is not good enough for a graph. Yeah, we have 3 points, and I did say you only need 3 points to graph a parabola, but I was specific and I said that one of them has to be the vertex. So let's find the vertex over here. Now again, this is not an x minus h squared plus k format. The vertex is not staring us in the face. We need the formula, which was h equals -b over 2 times a. So h equals -b, that's -5, the b was -5, all over 2a, which is 2 times +1. The negative negative cancels, so that's a positive 5 in the top. The 2 times 1 is 2 in the bottom. So the x coordinate of the vertex is 5/2, or 2.5, or 2.5, depending on the format you like. Now we got to find k by plugging this in. Because k is f of h, which is f of 5/2. And here's where you get frustrated because you're plugging in a fraction. You got some fraction math to do. So f of 5/2 is going to be parentheses 5/2 squared minus 5 times 5/2 plus 6. Let me make my 2 look a little prettier in the bottom. There we go. Make the 5 look a little prettier as well. Could do a lot of things with my handwriting to make it look prettier. That's 5/2 squared minus 5 times 5/2 plus 6. Again, we just plugged it into the original function up here. So f of 5/2. And if you prefer it as a decimal or a mixed number is not going to really work because of the middle operation. But you could try. And if this was something like a third or a seventh, you wouldn't want these as decimals either. So just be aware, fraction math's never going away. All right, 5/2 squared, that's 25 over 4. You're squaring the top and bottom independently. Minus 5 times 5 is 25. Leave the 2 in the bottom. Then a plus 6. And I'm going to go ahead and write that as a 6 over 1 because clearly we're going to have to add and subtract fractions. Your LCD here is 4. So f of 5/2. This is where we rewrite all the denominators as 4. And we divide and multiply to figure out what the numerators are supposed to be. So for the first one, 4 goes into 4 once. 1 times 25 is 25. It doesn't actually change. For the second one, 2 goes into 4 twice. 2 times 25 is 50. For the third one, 1 goes into 4 4 times. 4 times 6 is 24. So those are your equivalent fractions. So f of 5/2. Now that we have a common denominator, 25 minus 50 is negative 25. Negative 25 plus 24 is negative 1. So that is negative 1/4. And we finally, after all that arithmetic, have our vertex. It is the x value of 5/2, comma, what we just got, that's our y value, that's our k, so negative 1/4. So here's something that's fun. I knew that the x-coordinate of the vertex was going to be 2.5 the second I saw the x-intercepts here. Because your vertex will always lie halfway between two x-intercepts. The halfway point between 2 and 3, if you did a midpoint, something we just talked about last class, if you average 2 and 3, you get 2.5. Now, the y value has nothing to do with that, but an x-coordinate of a vertex is always halfway between two x-intercepts, if there are two x-intercepts. So we got some fractions to point. That's going to make this just slightly annoying, but we'll do our best. We don't see very large numbers, but we do have our fourth point to plot. So I'm going to do each of these steps in a half. 0, 6, so we need a pretty tall one. Let me get my fake ruler out again. And then let's do this. Good enough without the ruler. So let's go a half, 1, 1.5, 2, 2.5, 3, 3.5, 4. I'll mark the holes. Then the y values, we need to go up to 6. And again, I'm going to go in halves. We also need to go down at least 1. So a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. And then let's go down a half, and then 1 hole. So there's -1. We'll do our vertex in red. That's 5/2 comma -1/4. So that's right 2.5, and then down a quarter. Well, I did these marks in halves. So if going down 1 mark as a half, that means going halfway to it would be a quarter. So there's our vertex again. It is not here. That vertex, I'll even mark it just to be friendly. That has a height there of -1/4. And it went right 2.5. So that's our vertex. Then the other points we had, the y-intercept was at 0, 6. So that's left or right, 0 and up 6. And then our x-intercepts were at 2, 0 and 3, 0. I could go ahead and do the axis of symmetry, but since I don't need to use it to find extra points, I'll do it last. So now let's connect the dots with a nice looking U shape. Trying to figure out how much I want to bend. There we go. Just clean that a little. Not too bad. And then back up. And if I needed to use symmetry, since this height of 6 is left 2.5, I could go right 2.5, which would put us at 5. There's another point at 5, 6. But that's a 5th point. We don't really need it. So I'm not going to, oops, let me hit undo. Go. And then you just go a little past the height you have, little past the height you have, arrows. So there's our parabola. Now, if I did not ask for the axis of symmetry, if my math lab did not ask for the axis of symmetry, stop here. But if they ask for it, which I did, that's a dotted line, a vertical dotted line, splitting this in half, going through the vertex. And that AOS, that axis of symmetry, is x equals a number. It's supposed to be the x coordinate of the vertex, which was 5/2. It's this number right here. So that's x equals 5/2, or x equals 2.5. Again, I am not a stickler for formats. Mixed numbers are nice to gauge the size, but they suck to do arithmetic with. Give you a minute to soak that up. Okay. So we had to find the vertex by using the A, B, and C. We needed the formula because this was not x minus h squared plus k. We use the A to tell that it opens up, but I never actually used that fact. I just made it as a note. It's kind of a self-check. Yep, it's opening up. That's good. We found the x-intercepts by setting equal to 0. Again, you may need the quadratic formula here. I'm not promising anything. Which, by the way, chapter 3 officially starts my "you're now allowed a calculator" policy. In fact, every now and then I will pull out a TI-83 for reasons. So you are allowed calculators now as of 3.1 officially, even though they're take-home tests and I couldn't really enforce it necessarily without putting video cameras on you, which I'm avoiding for now. I'll have to. Which, by the way, that's a possibility for the final. We may use Zoom testing for the final. I'm not sure if they're going to mandate that or not. But we got a ways to go for that. That's a month from now. Anyways, back on point. X-intercept, set the function equal to 0, factor a quadratic formula, or if you really like it, complete the square. We got our x-intercepts. Y-intercept, plug in x equals 0. Boom, easy for this. Find the vertex. Arguably, that's the second thing I should have done, but again, the order of doing any of this doesn't matter because one thing doesn't affect the other. It's just finding a bunch of information. The vertex I saved for last because it involved the most pain in the butt arithmetic because of the fractions. but this can happen. If it happens in lecture notes, that means it might happen on a test question. I'm not going to say you're never seeing fractions or decimals again in your life. You definitely will. We plotted our points. We made sure we knew which one was our vertex. We connected them with our nice friendly parabola shape. And because I asked for the axis of symmetry, I gave us a vertical dotted line. Okay. B. F of x, same instructions. Negative x squared minus 2x plus 1. So again, not in vertex form, which means we will ultimately need a formula to find the vertex. I like to identify the a's, b's, and c's. They're -1, -2, and +1 respectively. Wow, it's already 2:40. Time flies when you're having fun. So since the a is negative, it opens down. But again, that should just be confirmed when we go to graph it. Let's go ahead and find the vertex next. Let's do it in the order I suggested. Well, the h would be -b over 2a, which is -2 over 2 times -1. Lots of negatives. 3 of them makes the whole thing negative. 2 and 2 cancel, so the whole thing's 1. That's our x-coordinate of the vertex. K, we just plug that in. So negative, parentheses, -1 squared. Watch out for that. This says -x squared. So negative, then the x value being squared in parentheses. Minus 2 times -1 plus a 1. Now these negatives do not cancel. You have to work inside out. You have to follow order of operations. This -1 squared, in fact, for emphasis, let me make this outer negative green again, just so you can see I'm bringing that one down. I'm not using it yet. The parentheses -1 squared is a +1. I see more than half of my students mess that up right there. The -2 and the -1 make a +2, then a +1. The -1 and the 1 cancel, so this whole thing is just 2. So K, which was the f of -1, is 2. So the vertex as a point is -1, 2. That's our lowest or highest point. Since it opens down, it should be the highest. Next, we'll find the X-intercepts. I'm gonna go a little quicker for a second. That's when we set the function equal to 0. So we go 0 equals -x squared minus 2x plus 1. I do not like the fact that the leading term is negative, so I'm gonna multiply all terms by -1. I'm going to multiply the left and the right side by -1 so that I make everything positive in a leading term. I only care about the leading term being positive. So 0 equals +x squared plus 2x minus 1. This is a much friendlier version to factor or do the quadratic formula with. Trust me, trust me, trust me. They both suck if you leave that a negative. Factors of 1 that subtract to 2 don't exist. 1 times 1 is the only factor pair of 1. 1 minus 1 is 0. This is prime. So we need the quadratic formula. I warned you about that, didn't I? Let's go up here in the interest of space. So that's x equals -b, so -2, plus or minus, big old square root, b squared, which is -2 squared. Same a, b, and c from before. I'm using these numbers here. Then minus the 4 times the a, which is 1, times the c, which is, well, I'm sorry, hold on. You can use those. I'm not doing anything wrong, but I was trying to prove a point. I want to use the new version. So now let's call A positive 1, B positive 2, and C negative 1. Sorry about that. Again, you can use the quadratic formula with this version of A, B, and C, but as I just mentioned earlier, it sucks, it's more difficult. And it has everything to do with the fact that the bottom is a 2A, it's going to be negative, and it's going to throw a lot of features off. You want the leading term positive to factor and apply a quadratic formula. So that's x equals negative b, which is negative 2, plus or minus square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, which is 2 times 1. Again, you really don't like that bottom being negative. So x equals negative 2 plus or minus the square root of 4 plus 4, yes, plus, negative, negative makes it a positive, all over 2, sorry about that. That's x equals negative 2 plus or minus the square root of 8, all over 2, which is negative 2 plus or minus the square root of 4 times 2. 8 can be broken down. Can't take the square root of 8, but can we break it up? The square root of 4 is 2, so that's going to pop out. So we get x equals negative 2 plus or minus, and I'll show that in a different color. So I'm going to take the 4 out. Square root of 4 is 2. But there's still the other 2 inside, and that's all over 2. But guess what? There's a factor of 2 everywhere outside. So you can take a GCF out and cancel it, or you can just do it the shorter way. Each of these 2's divides and makes a 1. So x equals negative 1 plus or minus the square root of 2 for 1, which is just negative 1 plus or minus the square root of 2. We don't need to write the over 1. That was a lot of work to find that intercept. Those intercepts, excuse me. So your x-intercepts are negative 1 plus the square root of 2, comma 0, and negative 1 minus the square root of 2, comma 0. Those are the 2 intercepts. Now, we're supposed to be graphing this. We don't know exactly what square root of 2 is. So this is why, one of the reasons you're allowed a calculator, because sometimes we need to worry about graphing things that do have square roots. So a question that someone asked earlier is now relevant. But only in chapter 3, not chapter 2. So if you go to a calculator, you would see that the square root of 2 is about 1.4. Just rounding it to 1 decimal. And that's pretty close to 1.5, and that's what I'm going to use for graphing, because going right 4/10 and left 4/10 is going to be kind of a pain. So the x-intercepts, let's get the approximation to them. They are approximately, if this is adding 1.4, negative 1 plus 1.4 is 0.4, so it's about 0.4, comma 0. Negative 1 minus 1.4, same sign, add, keep the sign, would be negative 2.4, comma 0. And again, when I actually go to graph them, I'm just going to call these 0.4s 0.5s to keep it simple. We still have to find the y-intercept. That's the last thing we have to do. That's just f of 0, which is negative 0 squared minus 2 times 0 plus 1. Everything goes away but the constant at the end. F of 0 is 1. So the y-intercept as a point is 0, comma 1. So the points we have, we got our vertex at negative 1, comma 2. We got our 2 x-intercepts rounded to the nearest 10th, and our y-intercept. And these are not very large values, so I should be able to fit this all in here. Forget the ruler, which, by the way, is my textbook. Not that you cared. I probably should have used the ruler. Not too bad. All right. So let's see. I got to go left about 3 and about right a half. So let's go left 1, 2, 3, right 1. I'm just going to label these in holes. The y values, I see a +2, some zeros, and a 1. So we only need to go up 2. 1, 2. I'll plot the vertex in red, which is the -1, 2. That's left 1 up 2. That's our highest point, hopefully. Let's do the y-intercept next, since that's the next whole number, 0, 1. We'll do that in blue. So here's the y-intercept on the y-axis. Then the x-intercepts, all right, again, I'm calling that a 0.5, 0. So right a half, up or down, nothing. And then left about 2.5, up or down, nothing. And there are our 4 points that we'll make our little U shape from, where the red one is the highest or lowest, specifically the highest here. So something like this. Then I did ask for the axis of symmetry, so we'll split this down the middle and write AOS x equals -1. That's everything. Your homework problems, sometimes all you gotta do is paint the picture. Sometimes you have to individually list, oh, the vertex is this point. The x-intercepts are these points. The y-intercept is this point. So don't just think that you can pull out your TI-83, type this equation in your TI-83, and it gives you the answer. You're responsible for all of this information. So maybe you do all this and you go, well, I'm not sure. I don't trust myself. What does it look like? Give me a few seconds. Come on. It won't let me minimize everything. Okay, share screen, TI-83. All right, here's my nice little virtual TI-83, which, by the way, if you just Google TI-83 app, you'll probably find something in Google in the first or second hit. So that's nice to have. So if I go to my y equals screen, I can type that equation, and let's just do the last one. I'm not going to do all 4 that we've done so far. Negative x squared, what was it then, a -2x, and a +1. Then we hit the graph key. Man, that looks pretty good, doesn't it? So that makes me feel confident in my answer, but it doesn't necessarily tell me where the vertex is. It doesn't necessarily tell me where the intercepts are. Now, there might be ways to prove that, but I don't want to talk about that today. Aside from the trace feature. Oh, and look, it even shows 0, 1. There we go. But when you just move around, it shows you a bunch of wacky decimal numbers. You can type things. If I type in, let's say, -1, it'll show me the y value, which is 2. It'll also point me where it is on the graph. -1, 2 did actually end up being the vertex. Lucky guess, right? If I type in -2, shows that the output's 1. If I type in -3, shows the output's -2. So I can see that x-intercept is somewhere between there, but I can't just get it by typing a number in. Oh, maybe it's -2.5. Oh, -0.25, that's close. Maybe it's -2.4. Well, that's ridiculously close, but it's not exact because the intercept had radicals. And if I ask you what the intercepts are, you have to give me the analytic answers, not some decimal of whatever it happens to be. I don't know, -2.439. I don't know that off the top of my head. Okay. New share screen. Although I guess the TI-83 is still up there, isn't it? Sometimes it's not, sometimes it is. All right, so let's scroll down. We got 10 minutes left. We need to use them wisely. Let's talk about maxes and mins. Sorry if you heard me drinking my water. We've talked about maximum and minimum before. We talked about local or relative extrema, local maxima, local minima, and we said we could have multiples of these local extrema. When we're talking about these parabolas, there's only one hill or valley. It's one or the other, which means you're only going to get a maximum or you're only going to get a minimum. And it's not even a local, it is the max or it is the min. So if your graph points up, then it's going to contain a minimum. And if your graph points down, it's going to contain a maximum. That should be super easy if you just paint a picture. Let's paint a couple pictures. Here's a graph that points up. The vertex would have to be right here. I'll label it as V. That's obviously the lowest point on the graph, so its height would be a minimum. Or, if you have a downward-facing parabola, the vertex has to be the highest point. If it's the highest, then its y value is the maximum. Remember the phrasing that we had in the last chapter, that it's located at the x value and it is the y value. This phrasing right here is super critical. Well, the vertex is the highest or lowest point, so the vertex gives you your max or min. But the vertex has an x and a y value. The max or min is the y value. The max or min is always the y value. It's located at the x value, just like when we talked about local extrema. This is something even my calculus students get messed up half the time. I don't want to say half the time, maybe a third of the time or a quarter of the time, because they're not taking their time, they didn't pay attention, they didn't practice, they didn't do their homework, whatever it might be. Things are located at x values. When we talk about increasing and decreasing, we use x values. When we want to talk about a maximum or a minimum, we're interested in the outputs, so that's why we need the k value. So if I give you a quadratic and ask you what is its max or min, you are going to be doing the same thing we were just doing in the previous 4 examples, but only part of it. I don't need to know any intercepts. I don't need to know random points. I don't need to see the graph. I don't need to see the axis of symmetry. I just need to know what the vertex is. And then I at least need the y value. Maybe I'm interested in the x value as well. In the interest of time, let's just put example 3 up here instead of switching to the whiteboard. Identify, there we go, I can spell. If the function has a max or a min, then say what the max or min is and where it's located at. And we're going to do the function f of x equals 2x squared minus 16x plus 30. Now, looking at this function, you can immediately, this is me snapping my fingers immediately. I don't know if you can hear that on my mic or not. I can immediately tell you whether it's going to be a max or a min. And I do that based on whether this graph opens up or down. So the a is positive. So it opens up, which means it has to look like the left picture that you see on your screen. It has to open up because the a is positive. If it opens up, that means the vertex has to be the lowest point, so it has a min. It does not have a max. It has to have a min because the maximum is going to be infinity. It goes up forever and ever and ever. So how do we find the location? We find the vertex. That'll give us the location and what the max or min is. So the a is 2, the b is negative 16, the c is 30. Because this is not in vertex form, we need to use that formula. We got to go h equals negative b over 2a. As a reminder, h equals negative b over 2a. Let me switch colors. So h equals negative b, that's negative 16, all over 2a, which is 2 times 2. That's positive 16 over 4, which is 4. So the x coordinate of the vertex is 4. Then we plug that into the function to find k. So that's 2 times 4 squared minus 16 times 4 plus 30. So k equals, do not multiply the 2 and the 4 first, for the love of math. Follow your order of operations. Don't make me go on Facebook and embarrass you. Ha ha ha. 4 squared is 16. 16 times 2 is 32. If you do 2 times 4 is 8, and then 8 squared is 64, it's wrong. Trust me. It's 32. Minus the 16 times 4, well, that is 64. Also, there's a cool feature between these two numbers. 100% of the time, this one of these is always negative 2 times the other. It's just a cool pattern. You don't need to know that, but if you do it 10,000 times, it's nice to know. Because once I have the 32, I know the next thing is minus 64. 32 minus 64 is going to be negative 32. Negative 32 plus 30. I feel like I said something wrong. No, I didn't. It's fine. I heard a ding, so I thought someone had a question, but it wasn't. It was something else. 32 minus 64 is negative 2. Negative 2 plus 30 is negative 2. Negative 32 plus 30 is negative 2. So our vertex is 4 comma negative 2. And that's too far over. There we go. That's all we need to tell the max or min and where they're located at. So we already said it was a min. So the minimum occurs at, now that's the x value. Now you can just write negative 4 if you like, but I think it might help you for practice and studying. It's at x equals negative 4. The actual minimum itself is the negative 2. Now again, you can write just negative 2, or you can write y equals negative 2. And that's the answer. All right, so we did a pretty decent amount of work from 3.1 today, but we did not finish it. Some of these are some pretty long sections. We'll have 2 more examples to cover next time. I'll even put them on the screen for just a second. Minimize the product of 2 numbers who have a difference of 10. That one's going to be fun. So we're going to have some word problems. And then example 5, one of my favorite style math problems in the whole world, optimization, making something as best as possible. So we'll do this. We want to build a garden and have maximum area for that garden. Did I change the sign of H? Negative 4 and 2. Oh, I did. Okay, I put the negatives backwards. That's what happened. Thank you for catching that. The minimum was at positive 4. And it was negative 2. I got so focused when I was writing off the border and erasing that I swapped my signs. I'm sorry about that. The H was positive 4, the K was negative 2. So let me go back and change that. It occurs at positive 4. It is negative 2. Oh, that was right. I had negatives on both. Got everything right? It occurs at 4. It is negative 2. Thank you for bringing that up. So that will finish everything for the day. As a reminder, please remember all the test 2 jazz, reviews in Canvas. The test is in my math lab. It'll be available Monday through Friday. Start it early, practice it early, look at the review early. Please look at the review. It will help you greatly. Please get your homework done. It will help you greatly. It will boost your grade. It will make things better. Besides that, have a good day. This video will be available on the internet. I have an errand to run, so this might not be up until 5 or 6 p.m. tonight, depending on how long it takes for this video to convert, but I will have it up today, I promise. So if I went too fast on something, you can rewind, pause, all that good stuff. Have a good weekend. We'll see you next week.